Imagine someone suddenly tells you something unbelievable. Right now, without standing up, without taking a step, without even moving your hand, you are traveling faster than a fighter jet. In fact, you are moving faster than almost anything humans have ever built. And yet, you feel completely still. Your chair feels stable. The room around you feels quiet. Nothing is shaking. Nothing is vibrating. It feels like the entire world is at rest. But physics says something very different is happening. Right now, the Earth is carrying you through space at about 67,000 miles per hour. That is more than 30 kilometers every single second. During the time it takes you to blink, the planet beneath you has already moved several miles through the darkness of space. And the strange part is this: your brain cannot detect it at all. So the question becomes unavoidable. How can something move so fast and yet feel perfectly still? At first glance, this sounds like a contradiction. Our everyday experience tells us that speed should always be obvious. If a motorcycle races past you at high speed, you hear the roar of the engine. If a plane accelerates down a runway, your body presses back into the seat. Even a simple elevator reveals motion when it suddenly begins to move. Your stomach senses the change immediately. So why does none of that happen with the Earth? Why does the fastest journey of our lives feel like nothing at all? To answer that question, we must begin with a strange experiment you can imagine right now. Picture yourself inside a train. The train is moving across a perfectly flat landscape, but the ride is incredibly smooth. No bumps, no turns, no vibrations. Inside the train, everything looks normal. A cup of water sits quietly on the table. A book rests on the seat. You toss a coin into the air. The coin rises and falls straight back into your hand. Nothing strange happens. From inside the train, it feels exactly like standing still in a quiet room. But now imagine something surprising. Outside the train window, the landscape is rushing past at 300 miles per hour. The train is moving incredibly fast. Yet inside the cabin, there is no sign of motion. Why? Because everything inside the train is moving together. The seats move. The air moves. The passengers move. Even the cup of water moves with the train. There is no difference in motion between the objects inside. So nothing reveals the speed. This idea is one of the deepest secrets of physics. Motion is not something you feel by itself. What you feel is change in motion. When motion suddenly changes, forces appear. Those forces push on your body, and that is what your senses detect. But if motion remains constant and smooth, those forces never appear. Inside a perfectly steady system, motion disappears from experience. And that is exactly what is happening on Earth. The planet moves through space incredibly fast. But everything on the planet shares that motion. The ground moves with you. The air moves with you. The oceans move with you. Every city, every mountain, every tree moves together along the same path through space. Because of that shared motion, there is no internal signal revealing the speed. From our perspective, everything appears calm. But the deeper you look, the more extraordinary the situation becomes. Because the Earth's motion is only the beginning. Most people imagine our planet orbiting the sun like a simple circle. But the real motion is far more complex. The Earth does not travel around the sun on a flat track. Instead, it follows a constantly changing path through space. While the Earth circles the sun itself is moving. Our star is traveling through the Milky Way galaxy at more than 500,000 miles per hour. And it carries the entire solar system with it. Planets, moons, asteroids, comets, and every living creature on Earth. All of it moves together through the galaxy. So the Earth's path through space is not a simple loop. It is more like a spiral. As the sun moves forward through the galaxy, the Earth traces a corkscrew path around it. Every year, the planet returns to the same point in its orbit around the sun. But it never returns to the same place in the universe. Because the sun has already carried the entire solar system millions of miles farther through the galaxy. In other words, the place where you are sitting right now did not exist in this location 1 year ago. The Earth has moved far away from that point in space, and next year it will be somewhere completely new again. Our planet is constantly traveling across the galaxy, but the galaxy itself is also moving. The Milky Way is not stationary. It drifts through the universe along with many other galaxies. Clusters of galaxies slowly pull on each other through gravity. Huge cosmic structures shape their motion. So our journey has many layers. The Earth spins. The Earth orbits the Sun. The Sun moves through the galaxy. The galaxy moves through the universe. And all of this motion is happening right now. Yet your body feels none of it. This realization reveals something surprising about reality. Our senses are not designed to show us the universe as it truly is. They are designed to help us survive in a small local environment. For survival, detecting sudden changes matters. Detecting enormous, smooth cosmic motions does not. So our brains construct a simplified picture of the world: a stable ground, a calm sky, a still environment. Physics shows us that this picture is incomplete. The world is not a fixed stage. It is part of a vast moving system. But there is something even more fascinating hidden inside this idea. Because the fact that we cannot feel Earth's motion reveals a deep rule about the universe. A rule that scientists call relativity. The laws of physics work the same way for any observer moving smoothly. Whether you are inside a train, inside a spaceship, or standing on the surface of Earth, the same physical laws apply. Gravity behaves the same. Objects fall the same way. Light travels according to the same rules. There is no special frame of rest, no universal place where everything is truly still. Motion is always relative to something else, and this idea changes the way we think about the universe. Instead of a fixed stage where objects move, the universe becomes a network of relationships between moving things. Everything moves relative to something else. Nothing is absolutely still. But perhaps the most astonishing part of this story is this. Even though we are part of an enormous cosmic journey, life on Earth feels peaceful. Cities stand quietly. Oceans move gently. Clouds drift across the sky. And people go about their daily lives without noticing the incredible motion beneath their feet. It is one of the most beautiful illusions created by the laws of physics. A planet racing through space that feels like a perfectly calm world. And once you realize this, the simple moment you are living right now begins to feel different. Because the ground beneath you is not just ground. It is a moving world, a small blue sphere traveling through a vast galaxy, carrying you along with it, silently, effortlessly, right now. Now imagine something strange. Imagine that for just 1 minute, the universe suddenly removes the rule that hides Earth's motion from your senses. Nothing about the planet changes. The speed stays exactly the same. The Earth still moves at 67,000 miles per hour around the sun. But suddenly you can feel it. What would the world be like? The moment you wake up, the first thing you would notice is the ground trembling slightly beneath your feet. Not violently, but constantly. Because the Earth's orbit is not a straight line. It is a curved path, and any curved motion means there is always a tiny inward acceleration pulling toward the center of that curve. Right now, that acceleration exists, but it is so gentle and evenly shared that we never notice it. But in this imagined universe, your body would feel it. It would feel like standing inside a vehicle that is constantly turning. Your inner ear would sense a subtle sideways pull all the time. Walking in a straight line would feel slightly strange, as if gravity were leaning a little sideways. But that is only the beginning, because the Earth is not only orbiting the sun, it is also spinning. Every 24 hours, the planet completes a full rotation. At the equator, the surface moves at about 1,000 miles per hour. Right now, we feel none of that speed. But if your senses suddenly became sensitive enough to detect it, daily life would feel very different. Standing still would feel like standing on a massive rotating platform. Every movement would carry a faint sideways drift created by the rotation. If you tossed a ball straight up, it would land slightly to the side because the ground beneath it would have shifted during the flight. Pilots actually calculate this effect when launching long-range rockets. The rotation of the Earth subtly changes the path of objects traveling long distances. But normally, because we move along with the spinning planet, our senses never notice it. Now imagine feeling it constantly. Every moment of your life would remind you that you are standing on a rotating world. But the surprises would not stop there, because the rotation of Earth creates something even more fascinating, the Coriolis effect. This effect appears whenever objects move across a rotating surface. Air currents, ocean currents, even long-distance projectiles are deflected slightly because the planet beneath them is turning. This is why hurricanes spin in different directions, in different hemispheres. In the northern hemisphere, they rotate counterclockwise. In the southern hemisphere, they rotate clockwise. The rotation of the Earth subtly twists the motion of large systems. Right now, these effects operate quietly behind the scenes of weather and ocean circulation. But imagine if your senses were powerful enough to feel them directly. Walking north might feel slightly different from walking south. The movement of air around you might carry tiny sideways currents created by the spinning planet. Your awareness of the world would constantly remind you that you are standing on a rotating sphere. But even this is not the strangest part, because the motion of the Earth through space is not perfectly smooth. Our planet follows a slightly elliptical orbit around the sun. This means that sometimes the Earth moves a little faster along its path and sometimes a little slower. The difference is small, but real. Near the closest point to the sun, called perihelion, the Earth moves slightly faster. Farther away, at aphelion, it moves slightly slower. If your body could feel these changes, you would notice subtle variations throughout the year. A faint increase in the sideways pull during certain months, a slight easing during others. Your calendar would not just mark seasons of temperature and daylight. It would mark seasons of cosmic motion. But something even stranger happens when we think about the sun itself. The sun is not sitting still in the galaxy. It is traveling through the Milky Way at extraordinary speed, about 220 kilometers per second. That is more than 490,000 miles per hour. And it carries the entire solar system with it. Planets, moons, comets, and asteroids all follow the sun along this enormous path. But the path is not simple, because the sun also moves slightly up and down through the disk of the galaxy as it orbits the center. Imagine a horse on a carousel that also gently rises and falls as it moves. That is somewhat similar to the solar system's motion through the galaxy. Over millions of years, the sun oscillates above and below the galactic plane, which means the Earth's path through space becomes an intricate three-dimensional curve. If you could trace that path behind the planet, it would look like an enormous ribbon twisting through space. And that ribbon stretches across unimaginable distances. But here is where things become even more fascinating, because our galaxy itself is moving relative to something called the cosmic microwave background. This faint radiation fills the entire universe. It is the leftover glow from the earliest moments after the Big Bang. In a sense, it provides a reference frame for the large-scale motion of galaxies. When scientists measure the cosmic microwave background, they find something interesting. The radiation appears slightly warmer in one direction of the sky and slightly cooler in the opposite direction. This tiny difference reveals that our galaxy is moving relative to that ancient cosmic light. The speed of this motion is enormous, roughly 600 kilometers per second. That is more than 3 million miles per hour. And once again, the Earth is carried along for the ride. But none of this motion shakes our world. None of it disturbs the calm surface of the planet, because the laws of physics allow motion to be shared across entire systems. When everything moves together, the journey becomes invisible. This idea has a powerful philosophical consequence. It means that stillness is not an absolute condition. Stillness is simply motion that we share. When you sit quietly in a chair, you feel at rest. But that feeling only exists relative to the objects around you, relative to the floor, the walls, and the air. On a larger scale, you are moving with the Earth. On an even larger scale, you are moving with the sun. On a cosmic scale, you are traveling with the galaxy. Rest is always local. Motion is always relative. And this realization transforms how we think about the universe. Instead of imagining a fixed cosmic stage where objects move, we discover a universe where everything participates in motion together. Planets move with stars. Stars move with galaxies. Galaxies move within enormous cosmic structures. Everything is part of a vast dynamic system. But there is one final thought that makes this story even more remarkable. Despite all this movement, the conditions on Earth remain stable enough for life to exist. The planet maintains a steady orbit. Gravity holds the atmosphere close to the surface. Liquid water flows across continents. And biological life continues evolving across millions of years, all while the planet travels across unimaginable distances through space. The universe has arranged its laws in such a way that motion does not necessarily mean chaos. Instead, motion can create balance. The same gravitational forces that move planets also keep them in stable paths. The same cosmic dynamics that shape galaxies also allow quiet environments to form within them. And inside one of those environments, on a small blue planet orbiting an ordinary star, living beings have emerged who can look at the sky and wonder about the nature of reality. So the next time you sit quietly and feel the calm ground beneath you, remember something extraordinary. The world is not standing still. You are traveling through the universe at incredible speed, carried by gravity, guided by the structure of space-time, and moving through the cosmos on a journey so smooth that it feels exactly like perfect stillness. And the most amazing part is this: the ride never stops. Before we go any further, pause for a second and imagine something unusual. Imagine you suddenly gain the ability to see motion the way physics sees it. Not the slow motion your eyes normally detect. Not cars moving down a street or birds flying across the sky. But the deeper motion, the hidden movement that normally escapes human perception. If that ability switched on right now, the first thing you would notice is that the ground beneath you is not as solid and quiet as it appears. From your normal perspective, the floor looks perfectly stable. But with this new vision, the entire Earth would appear like a gigantic rotating sphere. Cities, forests, oceans, and mountains would slowly glide across its surface as the planet spins through space. Day and night would suddenly make perfect sense. The rising sun would no longer feel like the sky moving. Instead, you would see the Earth turning, carrying your location gradually into sunlight and then back into darkness. A sunrise would feel less like an event happening in the sky and more like your planet quietly rotating toward a distant star. But the rotation of Earth is only the beginning. If your new cosmic vision zoomed out just a little farther, you would notice something even stranger. The Earth is not sitting still while it spins. It is falling. That word might sound surprising, because when we think of falling, we imagine dropping toward the ground. But in physics, falling simply means moving under the influence of gravity, and the Earth is constantly falling toward the sun. Yet it never crashes into the sun. Why? Because it is also moving sideways extremely fast. Picture throwing a stone across a field. The harder you throw it, the farther it travels before hitting the ground. Now imagine throwing the stone so fast that the ground curves away beneath it. The stone keeps falling, but it never lands. Instead, it continues circling the planet. That is exactly what an orbit is. The Earth is falling toward the sun while simultaneously moving sideways fast enough to keep missing it. So the planet continues this graceful cosmic fall year after year. But if your cosmic vision zoomed out even farther, another layer of motion would appear. The sun itself would no longer look stationary. It would look like a bright star traveling through the Milky Way galaxy. The entire solar system would follow behind it like a small swarm of planets carried along by gravity. Imagine a glowing torch moving through darkness while tiny sparks swirl around it. That image is surprisingly similar to how the solar system travels through the galaxy. The sun leads the way. Planets spiral around it, and together they cross enormous distances through the Milky Way. But here is something fascinating. The galaxy itself is not a random collection of stars. It has structure. The Milky Way is a spiral galaxy, meaning its stars are arranged in enormous curved arms that stretch outward from the center. These arms are filled with gas clouds, star clusters, and newborn stars. They slowly rotate around the galactic center like the blades of a gigantic cosmic pinwheel. Our sun happens to sit inside one of these spiral arms called the Orion Arm. From our position, the night sky shows us only a tiny piece of this enormous structure. When you look up at the Milky Way on a clear night, you are actually seeing the dense disk of stars stretching across the galaxy. Billions of suns packed together across thousands of light years. But if you could travel above the galaxy and look down, the view would be breathtaking. You would see hundreds of billions of stars forming graceful spiral patterns. At the center, a region so dense with stars that it glows intensely. And hidden within that center lies one of the most mysterious objects in the universe, a supermassive black hole. This object contains the mass of millions of suns squeezed into a region smaller than our solar system. Its gravity dominates the central region of the galaxy. Stars orbit around it at incredible speeds, yet from our distant position on the outskirts of the Milky Way, its presence remains invisible to the naked eye. We only know it exists because of the way stars move around the center. Their paths reveal the powerful gravity lurking there. But black holes are not just destructive monsters swallowing everything nearby. They also help shape galaxies. Their gravity influences how stars move, how gas flows, and how galaxies evolve over time. In many ways, they act like anchors holding the central regions of galaxies together. But galaxies themselves are not isolated islands. They live in groups. Our galaxy belongs to a small collection called the local group. This group contains dozens of galaxies of different sizes. Some are small dwarf galaxies. Others are larger spirals like Andromeda. And the entire group is bound together by gravity. Over billions of years, these galaxies slowly dance around each other. Sometimes they pass close enough for gravity to stretch their shapes and trigger waves of new star formation. In the distant future, the Milky Way and the Andromeda galaxy will eventually merge, not in a violent collision like crashing cars, but in a slow gravitational dance lasting millions of years. Stars will shift into new orbits. Gas clouds will collide and ignite bursts of star formation, and the two galaxies will gradually combine into one larger galaxy. Yet even during such enormous events, the chances of individual stars colliding remain extremely small. Space is vast. The distances between stars are enormous. This is why galaxies can pass through each other without immediate chaos. But there is an even bigger scale beyond galaxies. If you could zoom out farther still, you would begin to see something incredible. Galaxies themselves gather into clusters. Clusters gather into superclusters. And these superclusters form gigantic networks called the cosmic web. This web stretches across billions of light years. Its filaments contain thousands of galaxies linked by gravity. Between these filaments lie enormous empty regions called voids where very few galaxies exist. From the largest perspective, the universe looks like an immense three-dimensional network, a cosmic structure so vast that light takes millions of years just to cross individual regions of it. And within this gigantic structure exists a tiny star system. Within that star system exists a small rocky planet. And on that planet, living beings have evolved who can think about the universe itself. Which brings us back to the original mystery. Why don't we feel the Earth moving? The answer now feels clearer, because our senses belong to a creature that evolved to survive on a planet, not to detect cosmic motion. The movements that matter for survival are small and immediate. A falling rock, a running animal, a sudden push or slip. Cosmic motions are far too large and far too smooth to disturb our senses. So our brain constructs a stable world around us, a world that feels still. But physics reveals the deeper reality beneath that illusion. The Earth is spinning. The Earth is orbiting. The Sun is traveling through the galaxy. The galaxy itself is drifting through an expanding universe. And you are part of every one of those motions. At this very moment, without doing anything at all, you are participating in a journey across the cosmos. A journey measured not in miles, but in astronomical distances. Yet, the experience remains calm, because the universe allows motion to be shared across enormous systems. And when motion is shared, it becomes invisible. So the quiet world around you is not evidence that nothing is happening. It is evidence that everything is moving together perfectly. And that perfect shared motion is one of the most elegant features of the universe, a planet racing through space. That feels like the most peaceful place imaginable. Now let's step even further away from our everyday perspective and look at something almost unbelievable. Right now, you probably feel like you are sitting in one place, maybe in a chair, maybe in a room, maybe inside a building that feels perfectly still. But if you could watch the path of the Earth from outside the solar system, what you would see would look nothing like the calm world you experience. You would see a planet tracing a gigantic path through space, constantly changing direction, constantly moving, never stopping for even a single second. And here is the strange part. This path is not a circle. It is not even a simple spiral. It is something much more complex, a constantly shifting trajectory shaped by gravity, motion, and the structure of the universe itself. To understand this better, imagine drawing the path of the Earth in space. At first, you might picture a neat oval orbit around the Sun, but that drawing would only be correct if the Sun itself were standing still, and it isn't. The Sun is moving through the galaxy, which means the Earth's orbit is actually stretched forward through space like a twisting ribbon. Every year, the Earth loops once around the Sun. But the Sun has already carried the entire solar system billions of kilometers farther along its galactic path. So the Earth never closes its orbit in the same location. Each loop happens in completely new territory within the galaxy. In other words, every year our planet travels into a part of space it has never visited before. The ground beneath your feet is literally exploring the galaxy. But there is something even more fascinating about the Sun's journey. Our star is not wandering randomly. It is following a gravitational highway around the center of the Milky Way. This enormous orbit takes about 230 million years to complete. Scientists sometimes call this a galactic year. To understand how long that is, consider this. The last time the Sun was in the same place in the galaxy where it is today, the Earth looked completely different. Dinosaurs had not yet appeared. The continents were arranged differently. Entire mountain ranges that exist today had not yet formed. During that time, the solar system has traveled through vast regions of interstellar space, clouds of gas, star-forming nebulae, ancient clusters of stars, and perhaps even the remains of long, dead stellar explosions. But stars do not simply travel through empty space. The galaxy contains enormous invisible structures that influence how everything moves. One of the most important of these structures is something called dark matter. Dark matter is one of the strangest discoveries in modern astronomy. Scientists realized that the visible matter in galaxies, stars, gas, dust, is not enough to explain how galaxies rotate. If only visible matter existed, galaxies should spin so fast that their outer stars would drift away into space. But that does not happen. Instead, galaxies remain stable. Something unseen is providing additional gravity. This invisible mass is what scientists call dark matter. We cannot see it. We cannot touch it. But its gravitational influence holds galaxies together. In fact, scientists now believe that dark matter forms enormous halos around galaxies, acting like a hidden framework that shapes the structure of the cosmos. Without dark matter, galaxies might never have formed in the first place. But dark matter is only one of the mysteries shaping our universe. Another even stranger force is pushing the universe apart. This mysterious influence is known as dark energy. In the late 20th century, astronomers studying distant supernova explosions discovered something shocking. The expansion of the universe is not slowing down. It is accelerating. Galaxies are moving away from each other faster and faster over time. Something is stretching the fabric of space itself. This unknown energy now appears to make up the majority of the universe. And yet, scientists still do not fully understand what it is. So while our planet quietly travels through the galaxy itself exists inside a universe whose largest forces remain mysterious. But even within this vast cosmic picture, the story returns to something surprisingly personal. Because every person on Earth is part of this motion. Your body is made of atoms. Those atoms have their own stories. Long before the Earth existed, the matter that now forms your body was scattered across the universe. Some atoms formed inside exploding stars. Others condensed inside ancient gas clouds. Over billions of years, gravity gathered those atoms into new stars and new planets. Eventually, they became part of Earth. And through the processes of biology and evolution, they assembled into living systems, into cells, into tissues, into human beings capable of thinking, which means the atoms inside your body have already traveled enormous distances long before you were born. They have participated in cosmic events far older than our planet. Now, those same atoms are continuing their journey as part of a living organism riding on a moving world. And perhaps the most fascinating part of this story is this. Despite the enormous scale of the universe, the laws governing it are surprisingly simple. Gravity pulls masses together. Energy flows from hotter regions to cooler ones. Space expands. From these simple rules, the entire structure of the universe emerges. Stars ignite. Planets form. Galaxies spin. Life evolves, and conscious beings appear who can wonder about the universe. But here is something even more remarkable. The stability of Earth, the calm environment that allows life to exist, depends on the delicate balance between motion and gravity. If the Earth moved too slowly around the sun, gravity would pull it inward. The planet might spiral closer to the sun, heating the surface beyond the limits of life. If it moved too quickly, the planet could escape the sun's gravity entirely and drift into deep space. Instead, the Earth moves at exactly the right speed to remain in a stable orbit. This balance keeps our world within the sun's habitable zone, where temperatures allow liquid water to exist. Liquid water is one of the key ingredients for life as we know it. So the motion of the Earth through space is not just an astronomical curiosity. It is one of the conditions that make life possible. The speed that carries us through the solar system is part of the reason oceans remain liquid and ecosystems flourish. Without that precise balance, our planet might be a frozen wasteland or a scorching desert. Instead, it is a world filled with forests, oceans, animals, and people. A small oasis of life traveling through a vast cosmic environment. And that realization changes the way we think about stillness. When you sit quietly in a room, it feels like nothing is happening. But in reality, your planet is crossing the galaxy. The galaxy itself is drifting through a cosmic web of structures stretching across billions of light years. And the universe continues expanding in every direction. Yet your experience remains calm, not because motion has stopped, but because you are perfectly synchronized with it. The Earth carries you along so smoothly that your senses cannot detect the journey. It is like floating in a boat on a perfectly calm sea. The boat may travel many miles, but if the water remains smooth, the motion becomes almost invisible. Our planet is that boat. The galaxy is the ocean, and the universe is the vast horizon stretching beyond it. So the next time you look up at the stars, remember something extraordinary. You are not just observing the universe. You are moving through it right now at extraordinary speed, carried by a planet that never stops traveling. And the most beautiful part of this story is that the journey happens quietly, so quietly that life can flourish. Cities can grow. People can sit peacefully and wonder about the cosmos, all while riding on a small blue world exploring the galaxy. Imagine the universe as a gigantic river, not a river made of water, but a river made of motion. Everything inside it is drifting, flowing, and traveling through space. Stars move. Galaxies move. Entire clusters of galaxies slide slowly across the cosmic landscape. And somewhere inside that enormous river is a tiny blue world carrying forests, oceans, animals, and billions of human beings. That world is Earth. And right now it is surfing through that cosmic river at astonishing speed. But here is something most people never realize. The Earth is not simply traveling through empty space. It is moving through an environment filled with invisible forces, radiation, magnetic fields, and particles. Space is not truly empty. It is more like an extremely thin atmosphere filled with energetic activity. For example, the sun constantly releases a stream of charged particles known as the solar wind. These particles race outward through the solar system at hundreds of kilometers per second. If the Earth had no protection, this constant bombardment could slowly strip away the atmosphere. But our planet possesses a powerful defense. Deep inside the Earth, molten iron moves in complex patterns within the outer core. This motion generates a magnetic field surrounding the planet. The field extends far into space, forming a protective bubble called the magnetosphere. When solar wind particles reach this magnetic shield, most of them are deflected. They flow around the planet like water flowing around a rock in a stream. But some particles become trapped near the pole holes where magnetic field lines converge. When these energetic particles collide with atoms in the upper atmosphere, something beautiful happens. The sky lights up green, purple, red. These glowing curtains of light are known as the auroras. Auroras are not just beautiful displays. They are visible evidence that Earth is moving through an active cosmic environment. Our planet is constantly interacting with the energy flowing from the sun. But the sun is not the only source of radiation in space. Throughout the galaxy, powerful explosions and extreme objects release high-energy particles. Some of these particles are known as cosmic rays. They travel across the galaxy at nearly the speed of light. When cosmic rays reach Earth, most are stopped by our atmosphere, but a small fraction penetrate deep enough to create cascades of secondary particles. In fact, tiny showers of particles from cosmic rays pass through your body every second. You cannot feel them. You cannot see them. But they are there, silent messengers from distant events in the galaxy. Some of those particles may have originated from exploding stars thousands of years ago. They traveled across the galaxy before finally reaching Earth. And during that journey, the Earth itself was moving through space along with them. But something even more fascinating happens when we examine the structure of space-time itself. According to Einstein's theory of general relativity, massive objects do not simply exist inside space. They actually shape the geometry of space and time around them. Imagine placing a heavy bowling ball on a stretched sheet of rubber. The sheet curves around the ball. If you roll a marble across the sheet, its path bends as it follows the curved surface. Gravity works in a similar way. The sun curves the space-time around it. Planets move along the curved paths created by that distortion. So when Earth travels around the sun, it is not being pulled by a mysterious, invisible force in the traditional sense. Instead, it is following the natural curves in space-time. It is like a train following tracks that have been shaped by the mass of the sun. This idea reveals something profound. The path of the Earth is not just motion through space. It is motion through space-time itself. Space and time form a four-dimensional structure that determines how objects move. And that structure is constantly being shaped by mass and energy. But space-time is not perfectly calm. Under certain conditions, it can ripple. When massive objects accelerate violently, for example, when two black holes collide, they create disturbances known as gravitational waves. These waves spread across the universe like ripples across the surface of a pond. When a gravitational wave passes through Earth, it slightly stretches and compresses space itself. The effect is incredibly tiny, so tiny that detecting it required some of the most precise instruments ever built. But in 2015, scientists succeeded. They observed gravitational waves produced by two black holes merging over 1 billion light years away. This discovery confirmed one of Einstein's predictions and opened a completely new way to study the universe. Instead of only observing light, we can now observe the vibrations of space-time itself. But here is something astonishing. Even as gravitational waves pass through our planet, you do not notice them. The stretching of space is so small that everyday objects remain unaffected. Once again, the universe hides its most dramatic events beneath the calm surface of our daily experience. Yet the deeper we explore, the more motion we discover. From the smallest scale of atoms to the largest structures of galaxies, movement is everywhere. Electrons move around atomic nuclei. Molecules vibrate. Planets orbit. Stars rotate. Galaxies drift. The universe is not a still place. It is a dynamic system filled with energy and motion. And Earth is part of that system. But perhaps the most remarkable aspect of this story is how stable our world remains despite all this activity. The same laws that create enormous cosmic motion also create balance. Gravity holds the atmosphere in place. Magnetic fields shield the surface from harmful radiation. Orbital motion keeps the planet at a stable distance from the sun. All of these factors combine to create an environment where life can exist. A thin layer of air, liquid water, moderate temperatures. From the perspective of the universe, Earth is a tiny island of habitability surrounded by vast regions where life would struggle to survive. Yet on this small island, life flourished. Over billions of years, evolution produced organisms capable of sensing their environment. Eventually, it produced minds capable of understanding the laws governing the cosmos. And those minds began asking questions. Questions about motion. Questions about gravity. Questions about the origin of the universe. When early humans looked at the sky, they saw stars moving slowly across the night. They wondered what those lights were. They wondered what held them in place. Today, we know those stars are distant suns, many with their own planets, many traveling through the galaxy just as our sun does. The night sky is not a static ceiling. It is a moving panorama of cosmic activity. And when you look up at it, you are not just observing distant objects. You are looking at fellow travelers in a universe that never stops moving. So the next time you feel the ground beneath your feet and assume it is perfectly still, remember something extraordinary. The calm surface of Earth is only part of the story. Beneath that calm lies a journey through space that never pauses. The planet is spinning, orbiting, crossing the galaxy, and moving through a universe filled with energy and motion. You are part of that journey, a passenger on a world surfing through a cosmic river. moving faster than you can possibly imagine, yet carried so smoothly by the laws of physics that the ride feels perfectly peaceful. Imagine something unexpected. Right now, while you are sitting quietly on Earth, the planet is not only moving through space, it is also carrying an entire atmosphere with it. This might not sound surprising at first, but think about it carefully. Earth's atmosphere is a thin layer of gas only about 100 kilometers thick compared to the planet's 700-kilometer diameter. From space, that atmosphere looks like an incredibly delicate blue glow surrounding the planet. And yet, this fragile layer of air travels through space with the Earth at tremendous speed. Why doesn't it get left behind? Why doesn't the atmosphere simply drift away as the planet moves? The answer lies in gravity. Earth's gravity acts like an invisible grip holding the atmosphere close. Every molecule of oxygen, nitrogen, and carbon dioxide is constantly being pulled toward the planet. But these molecules are also in constant motion. They bounce, collide, and spread out in every direction. The balance between gravitational pull and molecular motion keeps the atmosphere wrapped around the Earth like a protective blanket. Without gravity, the air you breathe would slowly escape into space. But gravity alone does not explain everything, because planets with weaker gravity struggle to hold on to their atmospheres. Take Mars as an example. Mars once had a thicker atmosphere and flowing water on its surface. But over billions of years, much of that atmosphere was lost to space. One reason is that Mars lacks a strong global magnetic field like Earth's. And that brings us to another invisible feature of our planet. Earth is surrounded by a giant magnetic shield. This magnetic field stretches tens of thousands of kilometers into space. It forms a protective region known as the magnetosphere. The magnetosphere acts like a barrier against energetic particles coming from the sun. When the solar wind, a stream of charged particles from the sun, reaches Earth, the magnetic field redirects most of it. Instead of hitting the atmosphere directly, those particles are guided around the planet. Some particles spiral along magnetic field lines toward the poles. When they collide with atoms high in the atmosphere, the collisions release energy as glowing light. This is how the auroras form. Green ribbons of light dancing across the polar skies. But auroras are more than just beautiful natural displays. They are signs that Earth is interacting with space. Our planet is not isolated. It exists inside a constantly changing environment filled with energy flowing outward from the sun. Solar storms sometimes release enormous bursts of charged particles called coronal mass ejections. When these storms reach Earth, they can disturb the magnetosphere and create intense auroras visible far from the poles. In extreme cases, powerful solar storms can even disrupt satellites and electrical systems. So while Earth moves quietly through space, it is constantly encountering waves of energy from its parent star. But the sun itself is not a quiet object either. The surface of the sun is a churning ocean of hot plasma. Massive loops of glowing gas rise thousands of kilometers above the solar surface. Magnetic fields twist and reconnect, releasing enormous bursts of radiation. Sunspots appear as darker regions where magnetic activity concentrates. And occasionally, the sun releases powerful solar flares. These flares can release as much energy as billions of nuclear bombs in a matter of minutes. Yet, despite this incredible activity, the Earth remains at a safe distance, about 150 million kilometers from the sun. This distance places Earth in what scientists call the habitable zone, a region where temperatures allow liquid water to exist on a planet's surface. If Earth were significantly closer to the sun, oceans might evaporate. If it were much farther away, the planet could freeze. The balance between solar energy and planetary motion creates the conditions necessary for life. But here is something even more fascinating. Earth is not the only planet moving within this habitable zone. Astronomers studying distant stars have discovered thousands of exoplanets, planets orbiting other stars. Some of these worlds lie within the habitable zones of their stars. Some may have oceans, some may have atmospheres, and a few may even have environments capable of supporting life. But detecting these planets is extremely difficult. Most stars are so far away that their planets cannot be seen directly. Instead, scientists detect them by observing subtle changes in starlight. When a planet passes in front of its star, it blocks a tiny fraction of the light. This small dip in brightness reveals the presence of a planet. Other planets are discovered by measuring tiny wobbles in the motion of stars caused by the gravitational pull of orbiting planets. These techniques have revealed an astonishing fact. Planets are incredibly common in the universe. Our galaxy alone may contain hundreds of billions of planets. Some may resemble Earth. Others may be completely different from anything in our solar system. But even as astronomers search for distant worlds, one thing becomes increasingly clear. Earth is a remarkably balanced system. The atmosphere protects life from harmful radiation. The magnetic field shields the planet from solar particles. The oceans regulate temperature. The moon stabilizes the tilt of Earth's axis, helping maintain a relatively stable climate. Each of these factors contributes to the long-term stability of our planet, and all of them exist on a world moving through space at extraordinary speed. But the most amazing part of this story is not just the motion of the Earth. It is the fact that living beings exist on this moving planet who can understand its journey. For billions of years, the Earth traveled silently through space without anyone noticing. Then life evolved. Eventually, intelligent beings appeared who could observe the sky and ask questions. Why do stars move across the night? What holds planets in their paths? What is the structure of the universe? Through centuries of observation and scientific discovery, humans slowly uncovered the answers. We learned that the Earth is not the center of the universe. We discovered gravity. We measured the distances to stars. We built telescopes capable of observing galaxies billions of light years away. And with each discovery, our understanding of motion grew deeper. Today, we know that our planet is part of a vast cosmic system, a system filled with energy, gravity, and motion. Yet our daily experience remains peaceful. We walk across the ground without feeling the speed of the Earth. We watch the sky without noticing the motion of the galaxy. And that quiet calmness is one of the most beautiful features of the universe, because it means that even in a cosmos filled with powerful forces and enormous speeds, there are places where stability emerges, places where oceans can exist, where life can evolve, where minds can grow curious about the nature of reality. Earth is one of those rare places, a small world moving through the galaxy, carrying billions of passengers along for the ride. And even though the journey is happening at incredible speed, it feels like the most peaceful place in the universe.